Hello and welcome to my tutorial on Mechanical Advantage, a fan favourite from some of you guys at home, I know. So, without further ado, let's get started. So, we're going to be looking at calculating the mechanical advantage and learning why, as designer technologists, that's very important for us. We're going to have to do some other calculations as well, and maybe some velocity ratio, and to calculate the efficiency of how good this classification lever is. Now, if you're not brushed up on the classification of levers, and you're unsure as to what classification lever the wheelbarrow is, then perhaps it's worth checking out one of my previous videos to brush up on some of those skills. Okay, let's get started. The first thing we need to know or recognise is that we're going to be measuring the force in something called newtons, and in your exam that'll be given to you as a letter N and telling us how much force is being played around this object. Now we've got to imagine that we've got some kind of load in here, or a weight acting on this, and for argument's sake here we'll say that we've got 300 newtons of force pushing down and weighing that wheelbarrow down to the ground. And for argument's sake we'll say that we've got 50 newtons of force picking it up. So as a wheelbarrow is designed to have mechanical advantage, it's there so that we can pick up things that are much heavier, something that we can't normally pick up very easily without it. Now, as designer technologists, we're expected to be able to calculate how efficient that is and work out what that mechanical advantage actually is. So, we're going to need to know some bits of information here. We're going to need to know how far things are apart, and that's going to calculate our velocity ratio. Again, for argument's sake here, let's just say that the handles of our wheelbarrow are around about 800 millimeters away from the ground. And to lift this wheelbarrow up far enough so that we can push it forwards on that wheel, we're going to have to do something about 100 millimeters. Nothing too big. Now here comes the fun part, actually calculating how this device is going to help us and how efficient that is as a percentage. So the first thing we need to be able to do is work out that mechanical advantage, and that's essentially done like this. We have the 300 newtons of force acting down, like the gravity, into our wheelbarrow, and we would simply divide that by the newtons of force that we're going to use to pick it up, which is 50. So 300 divided by 50 is 6. So our mechanical advantage is 6. Now, we also need to work out the velocity ratio. Now, the velocity ratio, or VR, is going to be the ratio of the 800 over the 100, written out as a fraction. Or we could simplify that and turn that into 8 over 1 and turn it into a ratio. We just need to turn it clockwise so that we end up with that. What that tells us is for every 100 millimeters that I lift, we have to do it 8 times to get it into the air. So that basically means our velocity ratio is 8. I'm lifting the wheelbarrow 8 times further than I should have to get the actual load up into the air. Now that we've worked out the velocity ratio and the mechanical advantage, we could do a calculation to work out the efficiency, or how good this wheelbarrow is going to be picking up our things. We would do that in this formula. Its efficiency is the mechanical advantage over the velocity ratio. Sounds really complicated and technical, but actually we're working with fairly simple numbers here. So we end up with 6 over 8. Now remember, at the start of the video I said we needed to calculate that into an efficiency as a percentage. Well, all we'd have to do then is to times that by 100 to get our percent. Now if you've got a calculator at home or you want to use your phone, I'll give you a moment to crunch those numbers for me and you'll get the answer before I do. That's 6 over 8, then times that by 100 to get your percentage. Otherwise, you'll end up with something like this. 6 over 8 would equal 0.75. We times that by 100 to give ourselves 75%. And there you have it. We've calculated the mechanical advantage of that wheelbarrow. We've looked at using the velocity ratio to find out how far things are going to have to be lifted, how many times I'm going to have to pick something up to be able to get it to lift. And then we've calculated how efficient that's going to actually be as well by using that formula, E over MA divided by velocity ratio times by 100 to give us that 75%. So, in today's session, we've been looking at mechanical advantage. We've used some velocity ratio and we calculated the efficiency as a percentage. For further guidance, there are more videos on my YouTube channel. Stay safe.